NCBM 0324, Section 1.4, Evaluating Functions Using Function Notation, Part 6. Now this last example has a new type of function called a piecewise function. And as you can imagine, we have all different kinds of functions, and you're going to see a lot of them in your other classes as well. And this is just one of them. So what does it mean to be a piecewise function? Well, you still have the function notation, but the only difference now is that your formula that you're using to evaluate your function has multiple pieces, right? It's kind of where the name comes from. It's made up of different pieces. Now, to evaluate at a piecewise function, we have to look at the other notation they give us. So when I see this x less than 0, what this is telling me here is that if I'm going to use the first equation, I can only use that for x's that are smaller than 0. So this is telling me when to use the first rule. If my x is greater than or equal to 0, whatever they're giving me to evaluate, then I know I'm going to use my second rule. So for part A here, when we have f of 3, well, 3 is greater than or equal to 0, right? 3 is in this spot. It's bigger than 0. So that means I'm going to use my second formula. I cannot use the first one at all because that's only allowed when my x is less than 0. So I'm going to plug in 3 into the x spot, evaluate, and we came out with the value of -2. Let's try that on B. Let's do another one from scratch here. Let's try this on part B. We have f of 5. So f of 5, if you need to, maybe something like this one, we're going to actually write out what our x value is. It's the 5. Because I don't know exactly which rule I'm going to use yet. I've got to figure that out first before I can write a skeleton. So if my x is 5, where does that belong? Is 5 less than 0? Is 5 less than 0? Nope. So I don't use the first rule. Is 5 greater than or equal to 0? Yeah. So again, this is the rule I'm going to use for this particular x value. So then here's my skeleton. -2 times that substitution part plus 4. So I'm going to plug in my 5. And we have -2 times 5. That's -10 plus 4. We have an f of 5 is equal to -6. And there's my answer. So it all depends on what x you're looking at. That'll determine which rule of the piecewise you're going to actually use. You do not use both, right? Because it's not allowed in one of them. It's only going to ever work for one part of the formula. Let's try C. We now have f of -2. F of -2. So this again inside tells me the x. So now we have x is -2. Which rule does that fall into? Is x greater than or equal to 0? Is -2 bigger than 0? Nope. So it looks like this time we're going to use the first rule because it belongs to this x being smaller than 0. So I'm going to have my skeleton. Notice there's a negative in front of that x, so I put a negative in front of my parentheses minus the 5. And I'm going to plug in the -2. And here it's really important that we keep track of these negatives. There was a minus from the function, a minus from the value. So negative turns positive. So now I have 2 minus 5. So f of -2 is equal to -3. And there it is. The x value is -2. The y value, the function value, is -3. 2 more. Part D, we have f of negative 10. F of negative 10. So x value is negative 10. Which of the two rules we have will I use for this problem? I can only use one, right? The x value will only ever fall into one of these rules. So x equals negative 10 looks to be the first one because negative 10 is less than 0. So I'm going to use my first piece of my function. There's my skeleton, again, minus from this x here, minus x. And then I'm going to plug in my negative 10. So I have f of negative 10. Negative turns positive, minus 5. And we get f of negative 10 is equal to positive 5. Good. Last one. One more. F of 0. So again, this is telling us that the x value that we're looking to analyze here, to evaluate, is 0. So back to our piecewise function. Which of these rules allows x to equal 0? Well, the first one is x is less than 0. It has to be smaller than 0, so I don't think that one will work. But is x greater than or equal to 0? Well, it's not greater than, but it is equal. Right? I do have that equality on that symbol there. So yes, I am going to use my second rule. And when we plug in 0 into our skeleton, we'll have negative 2 times 0. Well, that's just 0. 0 plus 4 gives me 4. And there it is. So function notation, however we use it, whether it's a piecewise, a single function like what we started with, or even those R of x, C of x, P of x examples, when we evaluate, it's that plugging in the number that's inside of the function notation to determine the y value. Give me the x, I plug it in, and that ends up giving me the y.